In this video, we're going to look at some more complex trigonometric graphs, and we're going to learn how to sketch them. So over here, we have y is equals to 2 sine x plus 1. But what's different here is the range of x on which we have to sketch this or draw this, okay? So that means our starting value, usually the graphs that we've done so far was 0, but this time it's going to be minus 180. So we're going to start from minus 180. So what I'm going to do is one by one, I'm going to plug in the values of x. So I'm going to start from minus 180. And the next value that I'm going to plug in will be 90 more than 180. So basically, I'm going to keep on plugging values, taking intervals of 90 degrees. Okay, so we start at 2 sine minus 180. And again, for this, I'd strongly encourage that you use the feature that you have in your calculator, okay, the table feature. But right now, we'll just do it manually. So at minus 180, we're looking at 1. And now I'm going to replace minus 80 with minus 90. So I'm looking at minus 1. And then we're going to replace this with 0. So we're looking at 1. Yeah, so at 0, it's 1. And then 90, so we're looking at 3. And then you have finally 180, which gives you positive 1. Okay. Now, whenever you're making a graph, it's very important to keep the shape of the curve. Like, for example, over here, I'm visualizing that, yes, it's a sine curve. So I'm keeping the overall shape of the curve in mind. Okay, so that's very important, which is why you should have memorized the shape of sine, cos, and tan. Okay, so here's 180. That means at the halfway mark, we'll have 90. And if we have minus 180 over here, so between 0 and minus 180, we'll have minus 90, okay? And here's 1, 2, and 3, and here's minus 1. Okay, so at 180, we have minus 1, so there you go. That's 1 point over here. At 180, you have 1, my bad. At 90, you have minus 1. At 0, you have 1 again. And at 90, you have 3, okay? And at 180, you have 1, okay? Now, before I sketch a curve, first let me highlight the points that the curve through which the curve will be passing. It's sort of important that you like hover your pencil and, you know, just get familiar with the shape of the curve, okay? So this is what I'm doing. I'm just hovering my pencil over the points so that I know the kind of curve that I have to plot, okay? So this is the kind of curve that I am going to plot. So there you go. We have ourselves a graph of 2 sine x plus 1. And that's it. Now we're going to move on to the next question. Okay, now in this question, things are about to get slightly more complicated. Okay, only slightly. Okay, let me just write this nicely. So you have y is equals to cos 2x, and you're going to sketch this from 0 to 360 degrees. But the thing is, we haven't really done any example where you have cos 2x. So when this happens, so you got to make some small changes to the way that you plug in values. Now, what's going to happen in this is that our one cycle is not going to end at 360 degrees. Instead, it's going to end at 180 degrees. Okay, and how do I know that? Here's how I know that. I know that my new period is now going to be equal to 360, which is basically the natural period, divided by the coefficient of x, which in this case happens to be 2. That means now I have the curve of cos is going to end at 180 degrees. And because my range is from 0 to 360 degrees, I will be able to make how many cycles? I'll be able to make 2 cycles. So there's this confusion amongst a lot of students that, oh, since you have cos 2x, so that naturally means that you're going to make 2 cycles. No, that does not mean that you will have to make 2 cycles. It's because that one cycle ends at 180 degrees and you can go up until 360. That's the reason why you're going to make 2 cycles. Okay, so that's something that you got to keep in mind at all times. Okay, now another thing that's going to change is the step. Okay, so now we're going to have a new step, and that new step is going to be 90 divided by the coefficient of angle, which is 45 degrees. Okay, so this is the step that I'm going to be taking, which means that this table is not going to be enough, and we're going to extend it slightly. Okay, but how exactly are we going to do that? Whoops, sorry. We'll do that on the go. Okay, so we'll start by plugging in 0, and then we'll plug in 45, and then we'll plug in 90, and then we'll plug in 135. So you can see what I'm doing is I am just increasing the values of x by 45 degrees, and then 180. Okay, now if you want to be smart at this point, I'll tell you how you can be smart at this point. Okay, and don't and not have to go through the pain of finding out values. Well, if you didn't want to be smart here, that means you would plug in values such as 225, and then you'd plug in 270, and then 315, and then 360. So I'll tell you like a small hack that you can do. Okay, so what I'm going to do is I'm going to first plug in values from 0 to 180, and this time, you know what, I'm going to use the table feature in my calculator. Again, I have a video on it, make sure to check it out, but at this point I just want to save some time. So starting 0 and at 360, step of 45. Okay, so now I know immediately I don't have to plug in values one by one. I know that at 0 it's going to be 1. I know at 45 it's going to be 0. I know at 90 it's going to be -1. At 135, 0. And at 180, where one cycle is going to end, it's going to be 1 again. Okay, and I'm not going to find out the remaining values. I'll tell you why. Okay, so at 0 it's 1. At 45, so I'll have to make a mark for 45, it's 0. At 90 it's -1. At 135, so 135 is going to be in between 90 and 180. So at 135 it's 0, at 180 it's 1, and this is where one cycle ends. So I'll just highlight all the points before making the final curve, and keeping the shape of the curve of cos in mind, I have made the first curve. Okay, now at this point I'm going to be lazy, and I am not going to find out the values of 225, 270, 350 and 360, because I know that I'll get the exact same cycle. Okay, now it's something you can't do because you'll be doing it on a piece of paper, but I can, so I'm going to take advantage of it. So I'm just going to copy the previous cycle and paste it, and this is where the other cycle ends. And if you did actually work out the values of, let me just quickly make some adjustments here, 360, 270, yeah, if you did actually plug in the values and work them out individually like the way we did previously, so you notice that you'd get the exact same value. So at 180 it's 1. Okay, so at 225 it's going to be 0, so it's going to start from here. And at 270 it's going to be -1. At 315 it's going to be 0, and at 360 it's going to be 1 again. Okay, so let me just fix this slightly and drag this up. Yeah, there you go. Okay, so there you go. Okay, the key takeaway from this is whenever the coefficient of x is other than 1, so the period changes, and because of that the step also changes. Okay, let's do more examples. So here we have 2 sine 2x -1 for 0 to 180 degrees. So again, this time also I'm gonna use my calculator, but one thing that I want to show you is that now the new period will again be 360 upon the coefficient of x, which is 2. And why am I using 360? Because 360 is the natural period of sine. And why did I use 360 previously? Also because 360 is the natural period of cos. Okay, so 360 upon 2 is 180. That means my new period is going to be 180 degrees, and the new step that I'm going to take will also be in fact 90 upon 2, which means 45 degrees. So this time also I'm going to be using the calculator, the feature in my calculator. Okay, the table feature. So 2 sine 2x -1, start at 0, and this time we have to end at 180, and step is going to be of 45 degrees. Okay, so I'm just going to highlight 180 so that I know this is something that I should keep in mind. So at 0 we have -1, so I'm going to switch to another color so the points are visible. At 45, okay, so I need to make a point mark for 45. We have 1. At 90 we have -1 again, and at 135 we have -3. Okay, so at 135 is going to be in between 90 and 180, so that's where -3 is at. And at 180 it's -1. So there you go, we have the graph of 2 sine 2x -1 from 0 to 180 degrees. And had it been from 0 to 360, so we would have just copy pasted the entire thing. Okay, I mean not literally like copy pasted, but we would have drawn the exact same thing. So one thing that I want to point out over here is that this time the coefficient of x was 2, but that did not lead us to getting 2 cycles on the graph. We still ended up with 1 cycle. Why? Because of the range. So the number of cycles, it depends on 2 things. It depends on the coefficient of x, because the coefficient of x decides what the new period is going to be, and it also depends on the range that's given to you. Okay, so don't just end up memorizing that, oh, when the coefficient of x is 2, you have to make 2 cycles. Okay, it doesn't always work like that. Okay, so this one's one of my favorite examples. Okay, it's y equals to tan 3x plus 1. Now, graphs of tan are sort of challenging, but they're also very pleasing to look at. Okay, so over here you have from 0 to 180, and the coefficient of x, you can see, is not 1 anymore. So that means what's going to change? The period and the step. So the new period is going to be 180. Why 180 this time? Because that's what the natural period of tan is. So 180 divided by the coefficient of x, which is 3, and 180 divided by 3 is 60 degrees. Now, one thing that I want to work out right now is how many cycles I'll be making. So I will be making 3 cycles. Why? Because one cycle will end at 60 degrees, and I can go all the way to 180. Not all the way, but yeah, I can go till 180. So that means I'll be able to accommodate 3 cycles, because 60, 60, 60 makes up 180. And what about the new step? Let's look at that also. The new step. So naturally, the step that we take for tan is 45, but this time 45 is going to be divided 3 ways. So that means 15 degrees. Okay. So again, using the feature or using the table feature. So tan 3 alpha x plus 1, start at 0, end at 180. Step is going to be 15. Okay, so I'll fill it up over here so you can see exactly what I'm doing. So at 0 we have 1. At 15 we have 2. At 30 we have error, so that means now the asymptote that we normally would get at 90 degrees, we'll get at 30 degrees now. And at 45 we have 0 again, and at 60 we have 1. And I'm going to stop here. Okay, I'm not going to take this all the way to 180. Why? Because I know that it's just going to be a replica of we're going to get the exact same values. Okay, so since this was a past paper question, I've taken a screenshot of the x and y axes that was given in the paper. Okay, so you don't have to worry about that. You don't have to worry about making the x and the y axis yourself. You'll be given that. Okay, so at 0 it's 1. So let's just call this 1, 2, 3, 4. At 0 it's 1. At 15, so 15 is going to be between 0 and 30. It's 2. At 30 it goes to infinity. So we're going to make those infinite dotted lines, which we call asymptotes. Okay, so, and at 45 it's 0, so I'm just going to mark that over here. And at 60 it is 1. Okay, so let's draw the first half of the first cycle. So that's what this is going to look like. And then after positive infinity, it's going to start from negative infinity, and this is what you're going to get. Okay, and from this point onwards you're going to get the exact same thing. The cycle will just repeat itself. Okay, so here's what I'm going to do. Again, I'm going to be slightly lazy and not find out the values. Instead, I know that the next asymptote that we will get will be at 90 degrees, and then after that, in fact, you know what, let's finish this part first, and then we'll figure it out for the third cycle. So previously it was 1 at 15. Now at 75 it was 2 at 15. At 75 it's going to be 2. And at 90 it's going to be infinity again. So remember, we're just copy pasting what we did previously. And then at what do you have between 90 and 120? 105, it's going to be 0, and at 120 it's going to be 1. So there you go. And then it's going to go to infinity at 150 degrees again. And between 120 and 150, what do you have? You have 135, do you? Yeah, at 135 it's going to be 2. So there you go. And then at 165 it is going to be 0, and at 180 it's going to be 1. So there you go. And there you go. Again, very pleasing to look at. That's the thing I like about the graphs of tan. Anyway, so that completes this question. So I have some more examples lined up. Okay, so here's another example that I'm going to solve. It'll probably be so there are more examples. Okay, so here we have y is equals to 4 cos 3x minus 1. Let's see what we're supposed to do here. So this is going from minus 90 to 0. So first things first, I want to find out the new period. Okay, so the new period over here, I'm going to do 360 divided by 3, which means 120 degrees. Okay, but this is kind of complex in the sense that you will not be able to accommodate one complete cycle. Why? Because it's going from minus 90 to positive 90. Okay, but nothing to worry about. We have to keep the shape of the curve of cos x in mind, and then marker values after, and then join them. Okay, so I'm going to use my calculator again. So for cos 3x minus 1. Okay, so the starting value is minus 90 this time, the ending value is 90, and the step, okay, so the new step that we're going to take is going to be 90 upon 3, which means it's going to be 30 degrees. Okay, so 90 upon 3, 30, press the equals to sign, wait for the magic. So now you have all your values worked out. At 90 it's minus 1, so there you go. At minus 60 it's minus 5. Okay, at minus 30 it's minus 1, so there you go. At 0 it is 3. All right, at 0 it's 3. At 30 it's minus 1. At 60 it is minus 5, and at 90 it is minus 1. Okay, so there you go. This is what we get, keeping the shape of cos in mind. Okay, no, I can do better than that. All right, there you go. There you go. And now you have your graph of y equals to 4 cos x minus 1 from from minus 90 to 90 degrees. Okay, so I'm just going to do one more example in this video, and the rest I'm going to do in the next video. Okay, so here you have y is equals to 2 cos x plus 1, and this time we have our angle in radian. Okay, now that's something you should be familiar with. If you're not, I'll see if I can make a video on radian also. Okay, so basically in radian 2 pi is equals to 360. Okay, so we're going to replace 360 with 2 pi. 180 we're going to replace with pi, because that's what half of 360 is, so that means that's what half of 2 pi will be. 90 is pi by 2. Okay, and 270 is 3 upon 2 pi. Okay, now with radian, here's something I would suggest, that if you were to use the feature of your calculator, it's not going to be very satisfying, because the x values, the calculator will end up converting into decimals, and unless you're absolutely sure that you've done everything correctly, then go ahead. But I personally prefer making a table for radian. Okay, so that way I'm more confident about the values that I'm taking and the values that I'm. So an important thing to keep in mind is that here you have y is equals to cos 2x. Okay, so we know very well that when you have the coefficient of x is other than 1, so you got to be more careful. So that means now the new period is going to be, instead of 360, it's going to be 2 pi upon 2, which means it's pi, which is basically 180 degrees. Okay, and the step, another thing that will change is the step. So the new step is going to be pi upon 2, which is 90, divided by the coefficient of x, which is 2. So that means the new step is going to be pi upon 4. And how many cycles will you make? You'll make 2 cycles, not because the coefficient of x is 2, because one cycle will end at pi, and your range allows you to go up until 2 pi. So that means you can make 2 cycles. Okay, so with this, like I said, I'm not going to be using my calculator. Instead, I will be using, I'm just going to be plugging in the values one by one and writing them on the table here, but I'll only do it from 0 to pi, because I know then I'll get the exact replica of then the next cycle will be exact identical. So 0, and then pi upon 4, and then pi upon 2. So what I'm doing is I'm constantly adding pi upon 4 to the preceding value to get to the next value, and then you will have pi upon 2, so 3 upon 4 pi, and then pi. Okay, so now I'm going to work this out, and we're going to see what the values are. So you have cos 2 alpha x, sorry, cos 2 times 0. So let's just make a nice bracket for that, plus 1. So at 0, you have 2. And now I'm going to replace 0 with pi upon 4. So at pi upon 4, we have 1. And then we're going to replace pi upon 4 with pi upon 2, where we have 0. And then we're going to replace pi upon 2 with 3 upon 4 pi. So we have 1. And then we're going to replace 3 upon 4 pi with just pi, so we have 2 again. Okay, so I'm not gonna find out the remaining values because, like I said, this is where one cycle ends, and we're just gonna copy paste it. So at pi upon 4 is gonna be in between 0 and pi by 2, so that's where you have 1, and at pi upon 2 it's 0, at 3 pi upon 4 it is 1 again, and at pi it's back at 2. So this is what the first cycle looks like, which means that the next cycle will also be exactly the same. So there you go, 3 upon 2 pi, and at pi upon 2 it's 0. So there you go. Okay, that's it. So I'm gonna keep it up until here for this video, and in the next video we're gonna be doing some more examples and some kind of questions where you're supposed to make two graphs and you're supposed to find the number of solutions and all of that. So yeah, some good interesting questions in the next video. So I'll see you then. Until then, take care. Bye bye.